Welcome to Osmotec's revolutionary ThermoFuel system. ThermoFuel is an innovative yet relatively simple process which converts waste plastics to diesel fuel. Utilising waste from commercial, residential, agricultural and industrial sources, ThermoFuel will produce a diesel fuel of extraordinary quality and cleanliness while diverting thousands of tonnes of waste plastics away from landfill each year. Now let's take a tour of the way that ThermoFuel works. Waste plastics are delivered into the main feedstock hopper as a 15mm flake. From there they are forced into the hot melt feed system. Melting the plastics at just under 260 degrees centigrade, the continuous feed auger delivers the material into the main chamber at a constant flow. Prior to feedstock inflow, nitrogen gas is introduced to purge the oxygen from the chamber and allow a fully effective pyrolysis process to take place. Inside the chamber, the temperature is set at between 380 and 420 degrees C. The agitator blades keep the mix thermally homogeneous. At the end of each production cycle, the inert residue char is automatically removed. The char generally has no adverse properties and can be landfilled. Generally, less than 5% of the input feedstock weight is reduced to char. Now let's return to the normal production flow line. The fuel gases are piped to the patented catalytic converter, where the molecular bonds of the long carbon chains are broken. This reaction creates a viable high-energy fuel gas with a cetane range between C8 and C25, peaking at C16. The converter has the unique ability to bring together short-chain molecules, again peaking at C16. No consumable catalysts are used in the process. Now, let's follow the gas line and see the processing of the light fractions and non-condensable gases. From the catalytic converter, the fuel gases flow through to the distillation column. Only fractions in the C8 to C25 range are condensed to the main fuel line. High volatile fractions are captured to form a light end product with similar properties to common degreaser. This valuable product is stored in its own tank. The non-condensable gases pass out of the distillation column, then to the gas scrubber, where sulfurs and other impurities are scrubbed by an alkaline wash. The gases are then returned to the main furnace as an additional heat source. This adds significant efficiency to the system's operation, and because of its closed-loop configuration, ThermoFuel emits extremely low levels of emission to atmosphere. From the main furnace, exhaust gases are vented and used to heat the catalytic converter. Now let's return to follow the fuel production line. Again, following the gas line from the converter, the system first recaptures the heavier gases of C25 and above. These gases are returned back to the catalytic converter, where they are again processed and reformed into the correct chain length. Gases of the correct molecular weight are cooled and condensed and flow down through the distillation column, then through a hydrocyclone where trace levels of contaminants, including water and residual ash, are removed. From the hydrocyclone, the pure fuel is pumped directly to the quality assurance tank. Certain fuel properties, which may be dependent on feedstock types or the environment in which the fuel will be used, are regulated in line at this point. Sulfur reduction, if required, can also be carried out. The fuel is clean, low sulfur, and complies with all regulatory fuel standards throughout the world, including the European EN 590 and standards throughout the US. From the QA tank, the fuel is pumped direct to the main storage tank, ready for use. ThermoFuel produces an excellent fuel suitable for all standard diesel engines, and engines require no modification for normal operation.
Ground.
We've got a process here that we reduce the size, so it makes it easier to go into our system.
Then heated.
Starts at 180 degrees Celsius, finishes at 300 degrees Celsius. And at 300 degrees Celsius, that turns into like chewing gum.
before being fed into a network of pipes. Heated to over 400 degrees Celsius, the plastic is transformed into gas and then liquefied in this big distillation column. And from this incredible alchemy flows a sticky brownish liquid.
That's the diesel, and that's good stuff. That is the diesel.
Yes, you heard right.
It's
Diesel.
diesel that can go into your car, and that's it. That came from your waste plastic out of your kitchen.
From 1 ton of plastic, Michael can produce over 900 liters of fuel, a conversion rate of almost 95%. But for Michael, there's nothing surprising in all this.
Plastic starts life as oil, and it comes from the barrel of oil that they take out of the ground. So what we've done is take it back to what it originally started life as, is a fuel, or as an oil, and we've refined that oil to make it into a diesel fuel, and that's what we can use in our vehicles.
This revolutionary procedure has seduced CETA UK. Via Blue Orange, the Suez Environment Investment Fund, an agreement has been signed with Sinar to build 10 similar plants in the UK. The twin goal, to recycle collected plastics that usually end up in the incinerator while providing fuel for one's fleet of trucks. As for Michael Murray, he uses the diesel from his plant every day. And it's even cleaner than the diesel from the pump.
This fuel is fine for straight into the car. It's good